Right, so we're going to graph an exponential decay function. We can either use a table of values, preferably transformations, and then identify key properties. So I'm going to do number 13 on here. This is a decay. We can tell it's a decay because our b value is 1/3, and that's a times b to the x minus h, and then plus k. So the a value is 2, b value, as we just said, is 1/3. Our starting point is +1, -1. So starting point from here. We go ahead and plot that, 1, -1. Go ahead and do horizontal asymptote, y equals -1. And from there, we want to go up your a value. So we're going to go up 2. If I go to the right, I have to multiply by 1/3. That's how for the decay we always go to the left. So that way we multiply by 3, and it just makes things a little bit easier. So that height of 2 gets multiplied by 3 and becomes a height of 6. The height of 6 gets multiplied by 3 and becomes a height of 18. This is really quite steep. If we went one more to the right, it would be a height of 2 divided by 3, so it would be 2/3 and all the way down here. So we'll go ahead and do our best graph. And then the key properties, our x-intercept is not clear, but this is the one that we can say, the only one. We can say it's between 1 and 2. Domain is all real numbers. Range is from lowest value which is -1. Doesn't touch it, so not included. All the way to positive infinity. No vertical asymptote. No active symmetry. And then the y-intercept is when x is 0, so that's going to be 2 times 1/3 to the power of -1 minus 1. 2 to the 1/3 to the power of -1 literally just flips it, and it's 3 to the power 1 over 1 to the power 1. -1, so that's 6 minus 1. And in fact, I can just read that off the graph as 0, 5. The graph was not the best drawing. It goes a tiny bit better. And there we go.